This video will be dealing with factoring the greatest common factor out of a polynomial. The first type of factor is the one you're most common with. That is simply numeric factors. To find the greatest common factor among numeric factors, you simply list the factors and pick which one is the biggest in both lists. Now, the way you list the factors is important. Many people learn to list the factors in a list method. They have the number 24 and they say 1 and 24, then 2 and 12, then 3 and 8, then 4 and 6, and they have to squeeze it in there. Or if they don't have a number like 24, perhaps they have a number like 12. And they say 1 and 12. And then they have 2 and 6. Then 3 and 4. And then they have extra space in the middle, so they'll say 5 and 7. Which doesn't even make sense. But nature abhors a vacuum. Humans don't like empty spaces, and so we try to fill them by putting any kind of numbers we can think of in its place. A better way of doing it would be with what's called the factor pair method. Factor pair, you put the 1 on one side on the left and the 24 on the right. Then you go down and you have 2 and 12, 3 and 8, 4 and 6. And then 5 is not going to work, and 6 is already listed, so we don't have to list it again. That is one of the benefits of the factor pair method, is once a number is already listed, you know you're done. You don't have to continue. There's a few other benefits. You'll notice that the left side here is sequential. 1, 2, 3, 4. You cannot help but keep track of where you are because it's always the next number from the last one you did. So that one comes in handy. Also, it's called factor pair because you can easily see the pairs of factors that go together. And that is going to become valuable to you in future skills. So once you have one set of factors listed, list another set of factors. Let's say we have 36. So we have 1 and 36, 2 and 18, 3 and 12, 4 and 9. 5 does not work, so we don't have to list it. Or you can write 5 and cross it out, so that you can keep track of where you've been, and then 6 and 6. This is always going to happen using the factor pair methods when you're finding the factors of a perfect square. You will always end up with the same number on both lists, at the bottom of both lists. That means you're done. So you either stop when the next number you need is already listed, or you stop when you have the same number at the bottom of both lists. Again, excellent way of knowing exactly when to stop. Now, the question is, what's the greatest common factor? Well, once we have both sets of factors listed, all we have to do is find which one is the biggest that's in both lists. And that would be the 12. So the greatest common factor, often referred to as a GCF, for 36 and 24 is 12. That's finding the greatest common factor of numeric factors. If we want to include another number, 35. And we have 1 and 35, 5 and 7, and we look at the list for the biggest number that's in all three numbers, all three lists. And that number is 1. The greatest common factor of 24, 35, and 36 is 1. Sometimes that's the best you can do. And that is always going to be true. 1 is always a factor of any number, and sometimes that's the greatest common factor, is just 1. And it's important to remember that, because there will be times when you have to acknowledge, well, the only thing that's common is 1, and so I'm going to use the 1. Now that's if you're dealing with numeric factors. You could also be dealing with variable factors. But it's the exact same thing. You simply list the factors and pick whatever's the biggest. So let's say we're looking at x to the 5th and x to the 3rd. The factors of x to the 5th, now we're not going to be able to do factor pairs on this, but we can list them, x times x times x times x. And the factor pairs, the factors of x cubed are x times x times x. So then we can see that, okay, we have a common x there, we have another common x there, and we have another common x there. So the common factor, the greatest common factor between the two is x cubed, because they both have 3 x's comprising them, but the x to the 5 just has a couple more x's. So if we were to look at y to the 4th, and let's say y squared, then we have y times y times y times y, and y times y over here. We have 2 common y's for both of them. You may begin to start noticing a pattern here. The pattern being that the greatest common factor in this case was y squared, and over here was x cubed. The greatest common factor is always the same as the smallest variable, the smallest exponent. So if we were to say, let's look at the greatest common factor between x squared, x to the 7th, x cubed, and x to the 5th, then we could know, oh, well, the greatest common factor is going to be x squared. If I turn that to x to the 21st, now the greatest common factor is going to be x cubed. If I make that x to the 13th, the greatest common factor is now going to be x to the 5th. If it's x to the 54th, then the greatest common factor becomes x to the 7th. It's always, always, always going to be whatever has the smallest variable, the smallest exponent. So we can use that as the means of picking the greatest common factor among variables, just whatever variable has the smallest exponent. Now if we put it all together, we still do the same thing. We list the factors, pick the biggest common factor. All we have to do is keep in mind that we're going to use the variables with the smallest exponent. So if we had something along the lines of 25x squared, let's make it crazy and say y cubed, and let's have 35x to the 4th y squared. Our greatest common factor, we'll look at the numbers first. The greatest common factors between 25 and 35, we shouldn't need to list all those, it's going to be 5. The greatest common factor for x squared and x to the 4th is going to be x squared. And the greatest common factor for y cubed and y squared will be y squared. Simple. Nothing too scary, nothing too hard, nothing to get freaked out about.